Hello everyone. Today we'll take a small topic from class 10th chapter 4, carbon and its compound. The topic is chemical properties of carbon compounds. Carbon and its compounds. Here the topic is chemical properties of carbon compounds. Let us take the first property, that is combustion. We are already having an idea that combustion is a process in which a combustible substance is burnt in presence of oxygen and it produces carbon dioxide, H2O vapors, an amount of heat and light energy. Let us see now how the combustion process takes place for various carbon compounds. Let us see, I am taking coal. It means there is a presence of carbon. When it is burned in presence of oxygen, that is heated, it produces carbon dioxide gas, amount of heat and light energy is also evolved. Here the carbon, that is coal, it is in the solid form. Let us see now another type of carbon compound. I am taking methane.
Methane is a gas. When it is burned in presence of oxygen, it produces carbon dioxide gas, H2O vapors, and amount of heat and light. This time I have taken carbon compound in the gaseous state. Now let us take ethanol, C2H5OH, that is ethanol, which is a liquid carbon compound. When it is burned in presence of oxygen, that is air, it produces amount of carbon dioxide gas, H2O vapors, heat and light. So here we can just see that by doing combustion, these carbon compounds, when it is burned in presence of oxygen, they are producing a good amount of carbon dioxide gas, amount of vapors, that is water vapor, and enormous amount of heat and light energy. So this is what your combustion process. This is the first chemical property of carbon compounds.
Let us take now the second chemical property, that is oxidation. This oxidation process is all about addition of oxygen to the substance, or it is also called as if there is a removal of hydrogen during the reaction from the substance is getting oxidized. Now for oxidation process to be considered for carbon compounds, we are considering some oxidizing agent. Here we have K2Cr2O7, that is potassium dichromate. We have KMnO4, that is potassium permanganate. We have HNO3, nitric acid. So these are the common oxidizing agent which we will use during some examples which I will specify here. This oxidizing agent used to oxidize the substance. Let us take the examples. The first one is, we have ethanol, CH3, C double bond OH. It is ethanol, an aldehyde group which is attached to the methyl group. Ethanol is there. When it is treated with alkaline KMNO4 or acidified K2Cr2O7, that is potassium dichromate with some few drops of acid, or you can take potassium permanganate with few drops of base. The al, that is your aldehyde group, is getting converted to oic acid. It will be CH3 C double bond O OH. Here it is called ethanoic acid. So for the conversion of ethanol to ethanoic acid, that is, it is happening of oxidation process. The ethanol is getting oxidized to ethanoic acid with the help of some oxidizing agent. Let us go with the second example. I am taking here ethene, C H H double bond C H H. It is called ethene. When ethene undergo oxidation process with the help of these oxidizing agent, here I am taking alkaline KMNO4, that is alkaline potassium permanganate. The ethene undergo oxidation and it form C single bond C H H OH H H OH. It is called ethylene glycol. So ethene is getting oxidized to ethylene glycol. Let us take the third example now. Here I am taking ethyne, C triple bond C H H. It is called ethyne. When ethyne undergo oxidation in the presence of alkaline KMNO4, alkaline potassium permanganate, it forms oxalic acid, COOH. This C is bonded with another carbon and this carbon is of oic acid. So COOH is bonded with another COH. It is called oxalic acid. So these are all different examples of oxidation process for different carbon compounds, and we come across that how ethanol is getting converted to ethanoic acid, how ethene is getting converted to ethylene glycol, how ethine is getting converted to oxalic acid, mainly because of the presence of oxidizing agent which oxidize these substances, that is a reactant, and convert into product form. We can have one more example. We have now ethanol, that is CH3 CH2OH. Ethanol, when it is treated with oxidizing agent, and here we are taking, I can take alkaline KMNO4 or acidified K2Cr2O7. It forms from ethanol to ethanoic acid. It will be CH3 CH2 CH3. It will form CH3 COOH, that is ethanoic acid. So how the alcohol have converted to ethanoic acid, that is your carboxylic acid, that is your acetic acid. Little heat is also required during the reaction. So these are some of the examples of carbon compound which is undergoing oxidation process and leading to the formation of new compounds. Let us see the third chemical property of carbon compounds. The third one is substitution reaction. Here, an atom or group of atom is replaced with other atom or group of atom from a molecule during the reaction. So this type of reaction which is happening is called substitution reaction. Let us take an example. We have saturated hydrocarbons. Saturated hydrocarbons show unreactivity or unreactive in nature. Let us take an example. I am taking methane. When methane is treated with chlorine, so it is fairly unreactive, reaction is slow. But when methane is treated with chlorine in presence of sunlight, a substitution reaction takes place and it leads to the formation of various different products. So here one chlorine atom will be substituting the hydrogen atom. So it will be CH3Cl plus HCl. The reaction will show the chain formation. So then CH3Cl further treated with excess chlorine in the presence of sunlight, it forms CH2Cl2 plus HCl. Further reaction will take place. It will be CH2Cl2 plus chlorine. In presence of sunlight, it forms CHCl3 plus HCl. Further reaction will take place, and finally the number of substitutions will take place, means a replacement of a hydrogen atom by chlorine atom till the number of hydrogen atoms which are placed or which are present in the main compound, it is not getting replaced, it is finally forming a specific type of compounds, that is CHCl3 plus chlorine. In the presence of sunlight, it will be CCl4 plus HCl. So this one is monochloro or chloromethane, this one is dichloromethane, this one is trichloromethane, and this one is your tetrachloromethane. Tetrachloromethane. So this is what your substitution reaction is happening. So with the help of the example that how the substitution of a specific type of molecule, that is your atom or group of atom, is replacing the hydrogen atom from the carbon compound, and this type of reaction is taking place in the presence of sunlight. Now let us go for the fourth type of chemical property of carbon compound, that is your addition reaction. We will see that here it is a reaction in which two molecules react together to form single product. So this type of reaction is called addition reaction. We are taking here unsaturated carbon compounds, unsaturated carbon compounds. And for unsaturated carbon compounds, we are having some idea that it is having the presence of double bond, or it may be having the presence of triple bond in it. So due to the presence of double bond or triple bond, they generally undergo addition reaction. Let us take some examples. I am taking the first example, that is addition of hydrogen. Addition of hydrogen. Here I am taking ethene, C double bond C, H, H, H and H. When ethene undergo addition reaction of hydrogen, this reaction will take place in the presence of catalyst. Here I am taking nickel or palladium catalyst. So this double bond will break down and the addition of two hydrogen atoms will take place to two carbon atoms, and it will lead to the formation of ethane, C single bond C, H, H and H, and to the second carbon also three hydrogen atoms are bonded and it is forming from ethene to ethane formation have taken place. This reaction will take place in the presence of a catalyst, that is nickel or palladium catalyst. Overall, this reaction is also called hydrogenation reaction. Hydrogenation reaction. Here we have converted the alkenes to alkanes. Now, hydrogenation reaction is also utilized in the manufacturing of vanaspati ghee from vegetable oil. That is your application of hydrogenation reaction. That is how vegetable oil is getting converted to vanaspati ghee. That is your solidified form. So this vanaspati oil undergo hydrogenation, that is addition of hydrogen, that is taking place in presence of nickel palladium catalyst. Generally, the catalyst used to speed the rate of reaction, increases the rate of reaction without affecting the reactants and product, or without affecting the reaction, it increases the rate of reaction, due to which the hydrogenation process go out fastly and the vegetable oil is getting converted to vanaspati ghee. That is your application for addition reaction. We also come across that ethene is a unsaturated carbon compound and ethane is a saturated carbon compound. In this way, the unsaturated carbon compound is getting converted to saturated carbon compound. So let us go for the second example. Now, I'm taking an example of how the reaction of, that is addition of halogen. Addition of halogen. So this time I am taking addition of halogen to alkenes. So I have taken an alkene called ethene, C double bond C, H, H, H and H. Now I am adding bromine water. Bromine water. So it will be taking place in the presence of carbon tetrachloride solvent, and the two carbon atoms in which the double bond is there, the bromine atom is getting attached. One bromine atom is getting attached to two different carbon atoms. It will be C single bond C, H, H and Br, H, H and Br. So it will be called as 1,1 dibromo mixed with ethane. So this way the addition reaction take place for different various carbon compounds. Thank you.